All right, welcome. Hello, Morgan. Hello, Jesse. All right, so, oh, hi.
That was very strange. I had like a few series of errors when I tried to log in. So I assume it's just on my device, but
Oh, yeah.
it was kind of strange. Hi, how are you all? We've been here in a while.
Yeah. So, yeah, that's great. Thank you for joining. So, this week we had a DevoWorm meeting, and we're getting ready for our GSOC / open source meetings that are starting in the first week of May. And I'll send out a message as to when those start. Make sure that everyone is back on board. And we've been kind of chomping at the bit here for this period because I think Jesse wants to do some things and Morgan wants to do some things. And of course, I want to do some things in addition to our open source reports on people's projects and things going on there. So it looks like it's going to be a good summer. Yeah, so in terms of the DevoWorm meeting, that was on Monday, and Susan had one of her tensegrity structures that she was showing to the group. She builds these tensegrity structures out of different materials to conceptualize them and to demonstrate them, but she's interested in modeling these in biological tissues. So it's not quite the same thing, there are differences in materials and material properties, but the principles are the same, the physical principles. So she was playing with that a little bit and showing people. You can't really see it very well here, but it's this translucent structure here with these struts and these where they join together. And those are important in the tensegrity structure, getting that periodicity right and everything. So she was showing that off. She got this from a place where they do a lot of modeling of human bone and human tissue. So they actually build them so you can adjust them along the different struts. And it's interesting because that's, of course, relevant to biotensegrity or tensegrities in biology. So she's got something specific to that, and she was showing the group. Then Karsh gave an update. Let's see if he presented anything. I don't think so. We had a discussion here, and I can't remember what it was about. Oh, okay. That was Karsh's update. And then Ashu actually is demonstrating her data sets that she's creating. So she's created a couple of data sets for DevoWorm. We haven't had data set creation in a while. We had some data set creation at the beginning of the project when people were trying to, get secondary data in shape for different papers and things like that. And then we've created data sets over the years for specialized purposes, from different papers or from different data of other model organisms that we would like to work on. So we've created data sets for zebrafish, synaptic data sets, and connectome data sets for C. elegans, and data sets for Drosophila, and some other specialized data sets that we've produced for diatoms. And so those are available to work on. If people want to work on a project, say, for example, they can work on them. But this is her contribution to that. Some interesting network-related data sets. So that was her. And then we had Vivek Mathur, who is a person who's new to the meeting. He's working with Mehul on a hackathon, and they're doing this computational biology hackathon where they're working on some data sets. And he was just showing me some work they were doing on a dental data set where they were aligning dental patterns and doing this with deep learning. So it's kind of interesting work that they were, and this is just like kind of a small toy problem. They just want to show kind of that they can put together a project and use some different techniques on it. Okay, so that was a lot of that, and then we had a discussion about that, and yeah, and then I presented this paper. This was from the Mind in Vitro group at UIUC, and they published a paper, and I know Morgan was very excited about this paper. This is computing with living neurons, chaos-controlled reservoir computing with knowledge transplant. So what they were doing was they were creating these neural cultures. They were, they had like the electrode array in the culture. They were growing up neural cultures, and they took these cultures and they trained them on some stimulus, and they recorded the output. And then, of course, they did this for a while, and then they were able to get learning dynamics for every culture. And every culture is different, so they treated them differently as dynamical systems, and doing this sort of chaos computing, or chaos computing combined with reservoir computing. And so they were treating these things as reservoirs, but also doing control techniques at the other end. So they're doing this sort of information processing near the edge of chaos. And then, of course, they were able to take those profiles, those dynamical systems, and use them to train a new culture. This is something they called knowledge transplant. So they were able to take the things that were learned by the previous cultures and train new cultures. It's really interesting. This has a lot of implications for biofabrication and other types of things. And then, of course, we talked about organoid intelligence and how this compares with organoid intelligence. So organoid intelligence is where they taught these organoid cultures to play Pong, very simple closed loop feedback control system. And this is, of course, something you can do just by stimulating the neurons and then getting a response back, and then training that to do some sort of simple task with a very few degrees of freedom. And so this is a little bit of an advance over that kind of thing, because you have this dynamical system that you're trying to replicate. It's worth noting that they weren't able to replicate every culture and every behavior as a dynamical system. Sometimes the attractor basins collapsed and they couldn't do it, but they were showing the learning process and how that works in the paper. So this is some example of that. We went over that a little bit. And of course, this has to do with the reservoir that you're drawing from. So we had a discussion about reservoir computing and how that works from sort of random state, as an initial random state, to something that is structured as an output, and how reservoir computing can deal with nonlinearities. So we talked about all of that, and then that was the meeting. So yeah, that was a little bit about DevoWorm this week. And again, we're getting ready for our open source GSOC meeting. So, if you're interested in participating this year, if you want to contribute something to that, please stay tuned. And we usually have it on Friday afternoons at noon Eastern time. So that's in North America's Eastern time. So figure out what time that is from where you are. Okay.
I have a brief question about that.
Yeah.
What are the I know the real deal starts in May, and I think the May is that the start of the community period too?
Yes, it does. So
Okay.
the first couple weeks are community period.
Okay. And I know we're processing some things internally about that. Is there anything, and I don't know if this is what you're going to talk about next or not, but is there anything that we should try to do now, or like, would you want to maybe have a meeting about what to do in this, like ahead of that? Because I know there's a bunch of things we all want to do, and I just want to not thrust anything upon someone
Yeah.
without preparation for it.
So I guess like in the community periods past, we've done like an overview of the different projects. So they know the project that they applied to, but there's so much more in the group, and knowing all those resources is important. So we usually go over that stuff. In like last year, I think I went over the annual reviews that I usually do for Oral and then for DevoWorm. So I usually do an annual review for each, and I usually tell them to go watch those videos and then highlight some of the active projects that we're involved in and maybe some of the inactive projects. And then, you're welcome to invite people um, in from outside, because it's not just for GSOC, it's for other open source stuff.
Yeah, I've been kind of I think last year we called it like open source summer cohort or something like that. I've been mentioning to a few people in JoPro and sort of outside of that proper that might want to stop by. If there would be a lot of people that could do it, it's just that they may not be able to come onto Friday noontime. But yeah, it's always a very exciting thing to do, and it's kind of a I don't know. I feel in between so many things, because I feel like the start of May is here right now and it's not yet. So I'm feeling kind of like not exactly hyper vigilant. That's a little bit too strong of a word. I've been around too many therapists, but I feel like all this stuff is about to happen. So I'm trying to just get ready for that. But I'm excited for it. If there's anything in particular you want to do about it, let me know. And see, even I'm sure Morgan has things to say now, but there's something to follow with Morgan later too about some California stuff as well. But yeah, I'll let you have the mic back and sort where you want to go next.
Okay. Well, did you want to give an update on the NYCWiC?
Yes. I don't know how noisy my background is right now. I apologize.
That's fine. Yeah.
In a commute of sorts and waiting for my stuff so I can leave and sit down on the desktop. Yeah, overall it was fantastic. It was actually going to be the and it might have been in reality the largest event of this conference series history. Like the most students came for this, so that was cool. There were some funny stories, something to say offline about the venue, which is mostly great except for a few things, kind of comically. But overall, it was a success, and I think the organizers were happy. I haven't been to one in person in a couple years, so it was nice that I could be there and kind of be in sort of hometown Albany area. That's all the nice stuff. When I get back to my desktop later, and if we have time, it's not urgent, I'll share a few things that are kind of relevant to what we've been doing. Or at least sort of Processor's orthogonal lab JoPro community at large, because there's been a few things that are I ended up being a poster judge, and the posters were really, really good and really interesting. I feel like a couple of years ago, a lot of poster sessions everywhere. And this extends to things here in Boston, and like the AI Cures conference, all of that. Everything was just throw your stuff into a GTP chatbot and have a wrapper. And I was like, okay, and yes, we're kind of dealing with that now with GSOC submissions and stuff. Like there's a lot of, it's very easy to make, GTP speak for you. on many fronts right now. But on a positive note, I think many of the posters were quite thoughtful, and they kind of, people have kind of gotten away from oh wow, technology, I want to do this thing, to hey, I'm in a specific domain, and yes, I'm using the technology to do some stuff, perhaps, or help with some analysis or whatever. But there's the element of actually trying to get a little bit deeper into specific problems within specific domains. And I'm very much, thank you, I'm very much like into that. Yeah. Hold on a second.
Yeah.
And so some of those specific things are a little bit, there's a number of updates around Black versus Indigenous, which sort of have a kind of a loose partnership of sorts right now, because some of the people in them overlap, and some of the things we're looking at are overlapping quite a bit. And one of those things is sort of, you could say journaling related, but technically it's about taking a user's entries about this particular topic, dealing with some tags, and creating, you could say very loosely, like obsidian graph-like structures from those tags, but in a way that's a bit informed about either certain structures or certain theories, or developing certain kinds of internal relations to them. So that's sort of happening in our group, or our network, if you will, our extended network of people doing cool stuff.
Yeah.
But at NYCWiC, there was a number of things. I just mentioned 3 of them, and I may be able to show the posters later. But one of them was someone who was making a very brand new, like, social media approach. And it wasn't just like, well, let's make another version of Instagram or Facebook or whatever. They were really incorporating a lot of the ills that have happened, and it was very, very informed. I was kind of funny because I asked them how much like, if you will, market research or whatever they did, and like, oh, we did a little bit, mostly just talking to our friends. But a lot of the things they were addressing were essentially a kind of a holistic take on, like, what how does social media fail and become a complete, it's not about social. It's about presenting the thing and getting the likes to the market. And it's not just like, I don't mean that just from a I can't post my dog and share with my friends anymore. Why? Like, you can do that in places if you want to. But I mean specifically, they did a very fine job of getting at what our actual user wants and needs in 2026, and how does this sort of address the failings of social media as it evolved? Because I was like, oh yeah, I was like one of the more earlier Facebook users back in the day, and how did it evolve since then? So they did a very good job of that, and there's some things there about like human-computer interaction that are quite deep. Second poster that I'll mention is someone doing kind of narrative story development, and I think they're using kind of an LLM to assist with that, to assist sort of like what appeared in the story, almost visual novel-like, but sort of narrativity related. And there was something unique about it that I can't quite remember to say the right way, so I'll just say it was very interesting in that particular context. And then give me like 2 more seconds and I'll talk about the third post.
Okay.
Thank you. Oops. All right. The third one is partially my favorite, because it was directly about things that have come up in Indigenous, things that have kind of come up here as well, but basically about user. It was a decision making, or like almost a strategy related tool or bot but it was very particularly grounded, and I have to follow up with him about this. It was very particularly grounded on almost narrativity, or no, not inhibiting the reflection or the agency of the user. It wasn't trying to. They had a very specific ways of trying to not push the user into not, because ChatGPT sort of has the certainty bias of, oh well, here's the best answer. I'm just going to present it like this. They were very particular about trying to draw the user out into supporting their decisions, but not trying to augment them too much. And I thought that was, to me, that's quite cool and related to things I'm very interested in. And I felt for them a little bit, because I don't think that poster was going to necessarily win the best undergraduate poster, but for people who are very interested in that space, the work they were doing is quite relevant. Like, it's quite relevant to many of the things that are happening at the MIT AHA group, the Advancing Humans with AI, that I am a frequenter of, their seminar series, things at the Gov Lab, and various forms of the governance and things that we talk about in that space. So three really interesting posters, and none of them won best undergraduate, best graduate, or the People's Choice Award. So that was, they weren't even necessarily quote unquote the best according to some of the judges. But I think it was quite heartening to see what many of the students are doing right now.
Yeah, that was great.
So,
yeah.
And in maybe like 15 minutes or so, I'll be able to show more stuff. So I don't know if Morgan wants to say anything, or you guys want to do other stuff, but there's more to say. It's just, I'm probably kind of limited at the moment.
Well, yeah, thanks for that update. We'll come back to that. Morgan, did you have any updates, or do you want to do that later?
Yeah, just give me one second here.
Okay.
I'm still kind of lost my voice.
Oh.
From the hackathon.
Yeah.
Excuse me. It's or I don't know. Maybe it was just also being with so many people.
Yeah.
And let me just switch over to the computer here.
Okay.
The hackathon was a rousing success. We must have had about like almost, I mean, certainly like 16 universities represented, which is terrific. Really snowballed in the last like half week. Okay. It's good. Wrong camera. Sorry. Give me 1 second.
All right.
Okay.
There
That's
we go.
that's better. Yeah. It was just wonderful. So this was the global NeuroHack. It was 3 days, Friday through Sunday, and 16 universities, but maybe 14 teams. Like, a few people grouped up. Well, actually, maybe 16 teams. There were people showed up that we didn't know. Like one guy was working on, I think, like speech decoding, and the students had a Discord, like a Slack for the organizers, and they're like, there's one guy working on he says he's Georgia Tech, but he's working alone.
Yeah.
like we're not sure how he even heard about this, because it was, it was a little strange in the sense that, I mean, I did have people showing up being like, hey, there's a hackathon. And I was like, yeah, but, like universities are sending teams of 5, like it's you kind of need to be with a team and, but it was great. And, I think Georgia Tech guy came second.
Oh, wow.
I mean, I think he was a bit of a ringer. There was also a mix of grad students and undergrads, and and historically we've been just undergrads, So that students competed in 3 tracks: Blue Sky, speech decoding, and Science Corp did a track, which was just awesome. So this is one of the co-founders of Neuralink who left, Max Hodak, has a company called Science. Worst name ever.
Yeah.
And like came up multiple times in the weekend. People like, "Are you with Science?" And then somebody's like, what do you like? Aren't we all? But they were so great. They sent a whole team. Like they sent like 3 engineers, 4 engineers, and a media guy.
Okay.
And what was also very cool was like how many freshmen actually came.
Okay.
And to that point, so the Blue Sky track winner was 5 freshmen from UC Santa Cruz. So that just goes to show, I mean, Blue Sky was like particularly suited for that in that you didn't have to build something.
Oh, okay. Yeah.
Right. So it was kind of a proposal, but like at the same time, I think they won the judges over with both the kind of like practicality of it and the presentation. I mean, I would say something. I would say like, for good or for bad, your Blue Sky presentation was very key.
Yeah.
Yeah, but the main thing being that the students left like super energized. The fact that they all took this huge risk of flying to San Francisco, for this in-person event, which had never been held before, right? was big, and but yeah, it was great to have so many people came out to meet with the students and help and mentor them, or serve as judges. We had the head of neurosurgery at Neuralink came to speak about the kind of work that they do. Precision was there, which is another one of the companies that started from people, co-founders leaving Neuralink and starting a new company. And I think that was also really great for the that was exactly what the students had asked for, was like, hey, it's not so much the financial prizes, but if we're doing this in real life, can we meet people and get to talk to people we wouldn't normally have a chance? And so I just, like so many people came through on that. And uh, and they had, we did have, like, I'm biased, of course, but we had a great venue for them. Not just the event space, but like I could, spread them out across this huge building. They could have, their own conference rooms and things like that to work in. So um, what I'm excited about is to see, in maybe a month or two, um, how many of those groups that I'm still talking to, how many of those groups are, um, they went back energized. That was the good thing. And um, like it was funny too, where I had organizers being like, I'd say like, oh, so how's it going? What are you working on? And then somebody's like, uh, actually, I was wondering, could I get a room so that I can go work on my homework? you know, um, like these are all students in the midst of their academic semester. You know, I yeah. So it was really great to have, one, to meet all these students that I'd been talking with for like 4 months, and um, and seeing all their work come together, and seeing like all these students show up who'd never been, because there's so many freshmen. um I'm hoping big things from this particular group in Santa Cruz. If they're just freshmen, like, what are they going to do as sophomores or juniors? um so it was great weekend. And then so some of this week has been just wrapping that up, as well as kind of catching up on things that I hadn't had time for um, the week before, as it kind of got crunch time. But I met with the head of the connection program. So this is the group that I worked with last year, teaching neuroimaging analysis to mostly biomedical engineering students, and radiology adjacent people in Africa. So this is a program run from McGill, professor who's at McGill, but has an AI and medical imaging lab in Lagos. And so really cool meeting in terms of just how the program is progressing. um, she has historically had two initiatives. One is Spark, which is more of the AI related, work in medical imaging. And then one's the connection, which is a bit more of the kind of uh, particular neuroimaging analysis of MRI data. It's also part of CAMERA, which is the democratization of MRI in Africa. So just really cool. So I'm joining the chair committee, or the kind of organizing committee for the group. And there's really interesting projects in terms of collecting normative data sets in Africa. So that's really exciting in terms of representing something equivalent to Enigma in Africa in terms of collecting a normative sample as well as beginning a program of imaging genomics. And as we know from large scale medical kind of global health initiatives, that it's super important to have that global coverage. Excuse me. So there's some work I can show real quick. excuse me. Some of the I'm not going to spell this guy's name right, but hopefully I can find. So there's a group at UCSF. Yeah, this is the funny thing being that this is based here in San Francisco, and let me. I am just putting in Augustine here, but his let me just get his scholar. Because it like he captures this kind of global health really well, I think. Or like what's possible with this global health. And one second. That's so important. Okay. So he's mostly been doing this in well, I shouldn't say only, but like he has his big focus as a Argentinian researcher. He has his big focus Latin and South America, and is really valuable in terms of not only capturing the kind of like genetic profile that is regionally distributed, but and this is the exposome across multiple regions. So I'll just put in one paper here, really indicative of his work. So it's exciting. We'll be teaching, so we've got a new cohort of analysis students, kind of like learning different neuroimaging, as well as a much larger group that's learning AI in medical imaging, specifically, working on those kinds of projects. And then there's this data collection piece to it in terms of actually seeing, collecting an African cohort of data and things that you can specifically do with that is also really important. But Adana has had I think it's one of her interests is to have that for the students to work with too. That like these are African students working on a really African neuroimaging initiative, that's actually making a contribution to global health understanding. And yeah, so that's also really exciting. A lot of so there's some grants that are focused on kind of some of the issues that I'd really seen with the students in terms of our compute resources and things like that. That's exciting to see the progress on that. Still remarkable progress. Although some, I think I'm perhaps interestingly getting to the point where now, Claude can't save me when the physics becomes the problem. So, it's I think a lot of my early successes have been, somewhat, not somewhat, mostly aided by the fact that in a lot of analysis pipelines, I had lots of clear examples to work with. So I was mainly, to some extent, I was really just re-implementing certain things in JAX so that it gives me this computational benefit, right? And then that computational benefit can be leveraged to provide a new kind of simulation-based inference that allows for somewhat of a different way of working on problems, and something that's very amenable to some novel approaches that are computationally efficient, as well as providing great kind of Bayesian analysis with uncertainty. Some of the work that I've started doing now is actually hitting some really open problems in computational physics. and I'm seeing now where it's just like, now Claude is making normal mistakes. Or like now, we don't have any right answers to draw on. So it's like kind of like the last papers on some of this. So the project to check out is actually called so sorry, it's just brain FWI. So for full waveform inversion, I'll just drop this in if anybody wants to see it. But this is a technique that was started in the 80s for geophysics. It's incredibly computationally expensive, and so to get preliminary results has been a really interesting. Now this is something where Claude has to run experiments. In the sense of Claude is trying things and they're potentially not working, or they're potentially making things worse, or they're good approaches but they blow up computationally. And I'm on this DGX Spark, which is it's a nice 128 gig unified memory device. but at even like medium resolution, this is the I'm getting out of memory errors. And so this is really interesting. It's a great place to be finally, where I can also try and run some of this work that that I started from. I mean, I've been running, especially in my quantum simulations, the kind of minority game, computational social science slash computational chemistry. Um, but this agentic SciML for like multi-agent systems to solve these particular kinds of problems where can it's a little, I mean, it is a little like an AI scientist. Um, uh, yeah. So I gotta say that interestingly, the approach that I've found to be the most successful is actually using an LLM to do evolutionary search algorithms, um, which I think is funny because that is not agentic. That's not the AI scientist approach. It's very much a kind of gecko approach. Um, um, but I found that has helped with a couple problems where there wasn't any clear answers from the literature or anything like that. and a grid search was especially with neuronal, so like large scale neuronal cultures where you really needed to find kind of like where particular nonlinearities existed in this kind of like lost landscape. Anyway, it's reached a really interesting spot. It's like I think for data analysis, I'm more convinced than ever that like you should be using Claude. When it's just putting together scripts and uh, of kind of like known pipelines and things like that. Been doing some really I've been doing some hardware development now. So you can see this in the free EG 128. So I've got this. This is a particular. This is a super low cost amplifier system that I can, basically almost approach, $1 per channel for a high density EEG system. And yeah, this is doing firmware development now. I've got Claude writing some, well, I should say rewriting some experiments that come from an old task that I would like to get going for next week. Is the GTech Spring School for Neurotechnology and Brain Computer Interface. And so I've got a couple things that I'm working on that I don't know whether I'll necessarily compete in the hackathon, but I would like to do something for the for this event. And there I can't say enough about how useful this is to have. I feel like it's not only that it is a useful coder, but it gets me it gets me past humps where I think I would have maybe given up in ways like they weren't so challenging, but to get to like stay that focused on something for the amount of time that it would need to be, whereas like Claude can be just doing this in the background is yeah, good for us multitaskers. Anyway, but
yes,
I think it's interesting to have it hit a problem where where I'm really up on the edge of something and seeing how seeing how it both approaches things, as well as like, this is one of those times where I think AI scientists is not something that, that these models are doing well yet. Or it's still jagged.
Oh yeah.
In terms of that. Yeah. No, yeah.
Oh, sorry. I was agreeing with you and I was also trying to test my mic, but I guess hi. Sorry about that. I totally agree. I've been one of my colleagues. I'll call my camera. I think I can call my camera now. Yay! Is this gonna work? Let's see. Yay! One of my colleagues they're not totally new to LLMs, but they're not used to prototyping certain things that are software, like making software to do something, and they thought something was going to like maybe take a whole month to get to a prototype stage, and just they could do it in like less than a week. And it was really interesting to see their process of what you're going through. You're obviously a much more experienced user doing certain technical things in very unique spaces. But I like that you specifically said whoops, you hold on a second. Okay, there we go. Sorry. You specifically said that we don't have the right answers to draw upon, and you're kind of hitting the limit of clause. And I feel like that's something that I think it's so interesting, because if the people you talk to who have no idea where that space is and what they see, versus the people that hit that space and have to do things kind of on the cusp or outside of it, is a really interesting space to see right now, because that space is changing too. Like that threshold isn't the same as it was even like 6 months ago. But like much, if someone hasn't done stuff in a year or two and they're just like, oh yeah, I don't know, it wasn't that useful, and now it's kind of at that space. So it's really interesting that in that way. And the I want to we can continue in any direction, but it's also heartening that like the poster session that I mentioned, it's kind of nice to see people. I don't know, I feel like there's a little bit of a return to like being able to better focus on some of the problems now. And I'm just happy that that's sort of, it's become a bit more in vogue to not just throw it at stuff, but people have kind of matured a little bit to like, okay, like what problems can we be solved can be solved now. And there's a lot to say in terms of like, we don't have to get into this now, but things I'm looking at with like the in the for-profit things that I'm doing that are like around where how companies are using these tools. There's quite a big trend in terms of minimizing for AI. Oh, we're efficient, but also just the sort of where I guess I'll segue into this. Maybe I can even share my screen and share this. I attended before I go into talking about the MIT AHA group. Anything you wanted to close on, Morgan?
Just excuse me. Just as I would like to make it a weekly topical piece in terms of what I see, the Vibe Coding Nights, which is a group at the Tower, see the topics that they cover, see the you know, what are the social media posts on this? Like you're saying, like I'm someone who's been doing software in neuroimaging for like, you know, God, almost 30 years. And so I kind of know this very small space very well. And I took another one of these Andre Karpathy tweets that set people off, and so, you know, because I've had, you know, generated this like ecosystem of projects, but I did something that he talks about recently, which is he says he's not using, you know, LLMs to do code generation as much as knowledge. I forget what he says, knowledge management or something like that. And yeah, so I've got another project that's just neuro-kb, and I'm doing what he talks about there, but using it specifically for neuroimaging, where it's like I've generated a wiki around neuroimaging and kind of multimodal neuroimaging, and excuse me. So again, just trying to use, you know, see if I can use this particular domain to be an example of some of the kind of work that Karpathy is talking about. Cognitive Atlas. Yeah, cool.
It's something that we've talked about before, but in terms of knowledge management, I as my previous comment, I said I've been listening to like some of the Krakauer complexity stuff and Levin, and I have a little project, and I want to basically I'm going to host an internship about the internship in short is like, you're going to read Krakauer and you're going to read Levin, and we're going to talk about it. Like that's the whole thing that I want to, it's kind of, it's that type of thing that's like in the old school paper pyramid. I don't know if we remember talking about those things. It's sort of like at a crux of the middle level where it's like, I need support with this and just to talk about it with somebody. And I have groups that are sort of doing it. I don't know if it's going to be like a cognition future thing or not, but in thinking about that, listening to the podcast, I'm like, geez, remember the Cognitive Atlas? We've talked about this like, I don't know, many years ago over different kinds of years. I kind of wonder if anybody talk about knowledge management, like both in a chatbot form of training it on this, but also just managing that knowledge, because I feel like it was a really cool project. And I think it's kind of fallen into it's, you know how there's that sort of era of papers in kind of like before the turn of the century that are like kind of cool and have some cool math, but didn't really get much popularity. And we're kind of going back now, we're discovering some of them. I feel like Cognitive Atlas is sort of almost like a project form of that it was basically pre-LLM or pre-GTP chatbot type stuff. So now, and thinking about the knowledge management stuff and thinking about the podcast and thinking about Krakauer or whatever, I sort of like, like I'm sure somebody at some point is going to take and just throw that into an LLM type thing, and it'll be really interesting and much more useful than it's kind of, you know, disparate. It's a clunky old website, and I feel like I feel like much in the same way now that a lot of like AI executive coursework is just people's courses being paid to a third party to make it into something kind of fancy, and then they're reselling it as like some multi-$1,000 training program. Like someone's just going to go through, you know, these old websites and just do this at some point, and maybe that'll be something. Maybe that'll be like a macro prompt one day. It's just take old websites like this and make it something.
Well,
it's like repurposing your VHS tapes. It's like kind of a vibe.
I didn't realize this was a Russ Poldrack project. Yeah. yeah, yeah. That's no surprise. Or like, yeah, he would be doing something before LLMs. Yeah, yeah.
I don't know Bradley's anything. I know Bradley's the person who I think showed me the cognitive atlas. I don't know.
Mm.
We don't have to talk about the atlas. It just was
No, I
in
mean,
my
but
notes.
I mean, one, like it doesn't surprise me that Russ would be doing something that is collaborative,
Mm.
right? Which is definitely one part of that, but um, but also just seeing, yeah, um, seeing the need for putting this together, or seeing, like, again, like trying to better understand the state of our science. And as we move into biological territory, how we don't have overarching theories that kind of like help us kind of plot knowledge where it goes, like in an atlas. So we kind of need to be, creating the atlas, but without knowing you know without the map. what's what's the right,
Yes, we'll just
um,
say yes,
yeah,
and this, we can move on to other things. But yes, that's
yeah,
where
yeah.
we are.
But, but that's cool. That's cool. Um,
I could go in so many directions from here. I'm gonna plug the NYCWiC social media page, just because the LinkedIn page, and partly because I am involved in that, but just for a brief preview of just how cool things are there. How can I share this? I'm gonna do a tab. You can see this tab now, I think. Yeah. Um, there's just been so many great stories from this. I went around with my phone, but I was like 50 yards away from a lot of things. I was zooming in, and but like really just a lot of these like kind of lower quality pictures that look like they're taken from a camera from like 10 years ago, just because I was so far away from on my phone. But like just a lot of great stories. A lot of people were sharing. Um, I really liked Carla, Dr. Rios. Her talk was great. People are sharing. These are all NYCWiC posts, but I retweeted many of them. Like many people on their own shared really good stories about that. So yeah, NYCWiC was wonderful in that sense. I'll go to next rapidly. I'll go through a lot of JoPro stuff. Two things. One, this will be quick. Shout out to, and this is something that I might. There's a slight chance I'll be in the Berkeley area in May. So if I am, I'll try to like coordinate somehow in some form with like saying hi, or at least doing some things in mid to Northern California, perhaps. I was joking with one of my friends that I go back to San Diego and get some of the JV's burritos, because we have these beautiful stories about JV's burritos in San Diego, which I didn't get to go to last time I was there. But potential California tour in the near future, I don't quite know yet. But either way, we had this happening. There is a survey here. If anyone knows, we're looking. One of the teams I'm mentoring with for UC Launch, which is a startup thing, would appreciate if anyone's a information security, compliance team, a CTO, engineering type stuff, and you're dealing with like AI stuff and security and compliance. There's a brief survey here that would help some of the people, just to get some feedback from people in the field. So if you know that, please reach out. I can send it to you. These are a bunch of local events here. But also shout out to Team Hexer, who's the team that I'm mentoring. They're doing some AI security compliance type things. They won, oh, I don't have the picture here. They won second place at the sort of launchathon. The UC launches this program for startups. Sometimes people who don't make it in Y Combinator go there. Like it's a very big program for UC, and we don't hear about it on the East Coast, but it's a great accelerated program, a lot of mentoring, a lot of development, a lot of fit to market, and a lot of how do you succeed in that space, which is very interesting to hear how that's changed in the last few years. But Hexer was second place. I'm going to post their picture on LinkedIn soon. But yeah, I might be there in town for the actual UC launch, actual end cap of the program, the demo day, which is May 6th, I believe. So we're considering. I'm considering what to do about that. I mentioned that very briefly. There's a bunch of other updates, but then also this finally came out. This is sort of the first post. It's a very simple post. It's a very generic. It's not that interesting. It's kind of just saying, hey, we're doing this stuff. But DigiNest has emerged. We're actually, I think we're at like 14 episodes, which is really just weekly meetings that are not really going to be episodic like a podcast. A lot of them are just sliced up and put some interesting chunks on YouTube or something. But for the sake of it, there's been a very interesting conversation happening. And Avery's not on here because Avery just set up their Substack, which is shout out to Avery, because Avery's kind of stepping out into, hey, I'm doing certain cool things. And it's been, I've been supporting and patiently waiting and encouraging them for years to do that. And I think Avery's ready. So I'm very happy for that. So Avery should be on here, but they haven't accepted the invite to this yet. But we have Kat Chang, who's mostly affiliated with Plot Twisters. So Avery, myself, and Kat are sort of Plot Twisters affiliated. Molly is not, but Molly is someone who I've known for a long time, but we ended up getting into the DigiNet discussion series because she works in, let's say, in technology. She works in technology and has a lot of interesting viewpoints and is very, I think she's very well spoken and has very good insights as well. So with this post is sort of just talking about DigiNest at large. We talk a little about the reflective agency framework, which is this thing from, it's a paper and a framework from MIT Media Lab. I forget if it's from Fluid Interfaces or where Min-Soo Kim's home base in the Media Lab is, but Patty Mays, Rose and Picard are like, old school folks in that space. And it was an interesting paper because it deals with like phenomenology a little bit. It deals with some ethics, and it deals with like sort of these technical structural ways to deal with how a user's narrative is being influenced. There's these 5 principles: internal organization, or internal origination, calibrated responsiveness, reflective ambiguity, transparency of mediation, self-continuity, ethical flourishing. They get some philosophy behind them and design imperatives. And so they have this, they tested a bunch of like chatbots, like Replica and other LLM type things to see how they deal with this. It's an interesting paper, but kind of what DigiNest is trying to explore is a bit of like, how do we look at technologies being made in ways that what are the pressures on someone's narrativity, on their ability to reflect, on their ability to source and know they're internally sourcing what's going on. Okay, yes. I don't know. I forget which post this is supposed to. Yeah, okay. This is the Jonathan Haidt post, those guy. So, but yeah, a lot of the, today I think we're losing the ability to think deeply at all. Like all this pressure on digiphrenia, present shock type things, right? So, and this is sort of a reference to Kat's working a lot on the Plot Twisters, storytelling cards, and creating some new things with them, developing them out, doing some prototyping. There's a lot more on that ahead. I think I'll briefly show her post. Like this is something that she's been working on. Is this? Oh, okay. Well, it's not there. I don't know if she changed it or whatever. Let's see. So yeah, a lot's happening in this space. There's a number of, I don't have a great way to show them, but like very soon, things will be published on the JoPro YouTube channel, because I've been trying to capture, Diginess is sort of like a slightly, it's kind of evolved into what the Cognition Futures Radio Group used to be like, except with a little bit more, like Avery's really actively playing with the technology. Avery is giving periodic updates on what they're trying to build, and we're having some theoretical discussion. And we read a couple papers by, we've basically reviewed these two papers as well. We don't go into them now, but just to kind of show them the persona vectors, which is sort of how, it's kind of a bit about drift and how, where your interlocutor, your AI interlocutor is sort of drifting and how and why. And then also, which is a bit more recent paper, a little bit more involved, this one about the assistant axis and stabilized language models. So you kind of have this, our last discussion was partially about this paper and how there's sort of these different archetypes, if you will, that it can basically drift towards as its approach towards you and the user, which is kind of interesting. Another interesting chart, but yeah. So just things that we're covering in that space and talking about, and it's leading to, I don't know. I know what Avery's trying to do is sort of Avery's prototyping and theories and work, and I'm not really at liberty to say certain things right now, but Avery is working on an interesting, I don't know if I should say theory or framework or prototype or something, around allostatic kinds, affordances, and the kind of signal processing. So I think Avery, how can I best show this? Avery, if you find Avery's, I won't show it, but Avery's launched a Substack, and then or is about to launch it, and then they're about page of the Substack. They get into some of the motivations we're looking at, which I think is, I'm very happy to see that they're kind of stepping into that now. The last thing I'll say is going to be about this. But before I get into this, any questions or comments for the general slew of JoPro Diginess type updates I've said before we move on? So, okay.
No, I hadn't seen your post here.
Yeah. This one here, and this isn't released yet. This is still a draft. So if either of you want to look at this more in depth later and comment on it, I'd be happy to get any feedback about it. But what I really wanted, what it was mostly inspired by, and I won't go through the whole post right now. I know we have time, but maybe I'll pick out some interesting things. But and we've talked about Krakauer in the complex world and his work on the papers in the past. He, the big in 2024 they released a series of foundational papers to complexity science, at least edited or like arranged by Krakauer. And just for context, one of the things that came up in oh cool, I'm so glad I had this here in this podcast, which is from 2023, before those papers were released. Krakauer and Sean Carroll are discussing in Mindscapes, are kind of discussing what's going on. I think one of the more interesting things at a high level
is Sean was asking, like, hey, so David, is your take on complexity science? Where is it orthodox? Is it heterodox? Are you where are you going with this, and how does the other people in the space feel about it? And he even asked a couple times, like, oh, so is complexity science pre-paradigmatic or not in the Thomas Kuhn structures of scientific revolutions type sense? Krakauer, and maybe he's a little bit biased, but I'm okay with this, basically said he believes that there's been enough happening. I forget exactly what the four legs of the table of complexity science are. One was like computation. I think one was about probably something to do with symmetry breaking. I can't remember, but he's basically saying the four pillars or the four legs of the table haven't necessarily been uniform, but they've emerged to a coherent structure in his mind. And largely that's around his take on teleonomic matter, which in a very rough and ready sense is about matter that encodes something about the environment, and so has this sort of decision-making process or choice or selection process. Those are more my words than his, but problem-solving matter with purpose, things that encode a bit about the environment and have some internal record or some way of he juxtaposes it to the analogy of a ball rolling downhill or a ball rolling uphill, and saying, well, the ball is just rolling along thing dictated by gravity in the environment. That's not necessarily encoding bits of the environment and making a choice. And it's like, he's trying to separate his view on complexity relative to, like, where does it separate meaningfully from classic or from physics. And so that's sort of his thing. And what kind of it's been on my mind a long time. Like, and I even kind of reference somewhere in here, or not in here, but I think in the Slack, I basically said, this is what I was thinking about before I had to launch data and direction and some other things in JoPro. And so now it's kind of like, it feels like a year later I'm picking it up. But what I will show on the other side of the coin is this from Michael, our oft-referenced Michael Levin. And so this is from December of last year. New terms in an emerging field. Here are some new terms you may encounter in my talks and papers on diverse intelligence and definitions. And it's just a set of bullet points with some links and some discussion. I won't go through all this either, but some of the more interesting things that I'm thinking about in terms of what Levin's doing, we know a bit about agentive materials and anatomical compilers, that magical future system, and morphogenesis. We know answerbots. Actually, the persuadability was kind of interesting for me. A spectrum containing different kinds of systems from mechanical clocks to humans and beyond, that organizes them with respect to what kinds of interventions, rewiring, set point editing, blah, 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 are optimal for prediction and control of that system. The question is what kind of approach is needed to persuade the system to do what you want it to do. And there's very interesting, and I think I mentioned this in I'll come back here, in here. What I'm doing in my post is kind of I'm cherry picking a few of these things and kind of loosely aiming to reconcile what Krakauer is doing at his sort of systemic, broader level of complexity. And I'm not even trying to say they're really talking the same thing necessarily, but it's really just it's still kind of a big open question to me of like, where do they overlap meaningfully or not? Because I feel like they're both doing things that I'm very interested in and think are important, and I'm just trying to see where do they go. Is there any way to tether them meaningfully to each other, or not? This is sort of an initial pass at me reconciling some things, and even in terms of agential material and teleonomic matter, there's a point in this discussion, and I think I'm just going to go through this entire podcast in a later post, because this podcast for me, and maybe it's because of where I am now, really helped me understand a lot of what Krakauer's stuff is, and it might be because he's like just finishing the or preparing to release the actual multi-volume papers themselves. But like it just seemed, for whatever reason, the way that he spoke about it connected a lot of things in my mind in this time. And one of the things he specifically mentioned, and I don't have a timestamp for it, but somewhere in here, he kind of addresses a little bit of what I think is quite related to the axis of persuadability, in terms of, because he was saying like different agents or different teleonomic matters, and I'm blurring the two camps here, essentially are more trainable than others, or have a little bit more agentic, in a Levin sense, agentic drive to do a very specific thing, and are not as persuadable, if you will, to go away from that. So I'm curious to kind of dive deeper into what these two folks are saying and where is it going to that end. Agents of materials, teleonomic matter, persuadability, and spectrum of interventions. Yeah, this is kind of what I was talking about just now. I don't necessarily like, I'm not so sure about that. Teleophobia, which is actually from Levin, is quite interesting. And I feel like his take on teleophobia, we all remember this diagram from the 1943 paper, and Levin mentions it all the time. I wrote a big blog post about it here a while ago. And he uses teleophobia to talk about the unworded fear of erring on the side of hypothesizing too much agency into explaining or predicting a behavior system. And it's kind of this, I don't know, 2026, 2025 take on, like the opening of this, like, well, not the opening, but in the opening of my blog post, I pulled a quote directly saying, when the authors from 1943 wrote this about the classification of tabulated above for done for several reasons, blah, 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 blah. It emphasizes the concepts of purpose and teleology, concepts which, although rather discredited at present, are shown to be important, and talk about trying to get this uniform behavioristic analysis approach and their ascending little diagram. But so Levin's sort of trying to, continuing to do this work of sorting out teleology and purpose from his angle. And then you have Krakauer, who is teleonomic matter. So I'm kind of like, I just want to kind of see where this goes. He talks about the Platonic space in this is Levin's term. And I do think, what's the best way to show this one? I pull some of the quotes. This is a direct quote from him. But as a slight side note, I think a lot of what Avery's trying to do, and I'm kind of attempting to bridge some of this, many things here. I think Avery is attempting to venture into some of what Levin's getting at with the Platonic space stuff. And even in terms of the anthropic papers, it's like, what are these sort of natural drifting points that the assistant personalities are kind of going towards these extremes, and in LLM space, it's trained on human language, so like those things reflected in the language are sort of a there's a reason why they show up in language or through something trained on internet and broad language at scale, sure. But I think there's something not even outside of language and human not even anthropomorphizing it too much. But I'm very curious to see where Levin's exploration of these spaces. I envision a broader latent space which contains not only the seemingly low agency facts of mathematics, but more complex, higher agency patterns, as well as behavioral competency kinds of minds. These causal influences of mathematical facts and the physical world suggest a kind of interactionism. The mind-brain relationship is symmetrical to the relationship between mathematical objects and physical ones. And he proposes this big program, which I have yet to fully read and comprehend, and it's not gonna show up here. I don't know why it's not showing up. Oh, that's weird. I clicked the same link twice and now it shows up this time. But like this paper, this Ingressing Minds paper, is supposedly his research program. And when was this made? A couple of years ago? Last edited, yeah. So like one of the things I want to do and why I want to get like an internship and a reading group about this, like I want to understand where the heck is Levin trying to go with this? And how does it mesh with Krakauer's complexity stuff? Because I feel like they're both, it kind of reminds me of like the old Johann John Logiciel, when Johann was reading the Logiciel book about, new types or different ways of using maths to explore certain things on the horizon. So I know this is like, oh, all these ideas and stuff. I'm gonna come back here and basically the selflet's also incredibly interesting, but I'm basically gonna come back here and get this back to like, this is going to be a slower burn thing, and I don't really know where this fits, but I feel like there's enough underlying stuff between some of my personal priorities right now are essentially complexity stuff, which isn't really the priority. It's just, it's been lingering so long in the background, it's kind of just burst through again. And then I'm doing a lot of work on navigation and selection of choices. I had this whole primer on like spatial navigation and different kinds of agents dealing with navigating things, whether it's epistemic navigation or obvious spatial navigation in the physical environment or other things. So some of my personal, like what I'm doing under the hood of a lot of things is, yes, diginess is happening, data indirection is happening at a different scale. We're kind of wrapping that up. Can I show this? Yeah, I'll end with something from one of our interns that they're about to post. But navigation, selection and choices, and sort of this alternatives, like the comprehension and existence or like affordances, all these topics, but like alternatives. So like navigation, alternative selection, choices, and there's sort of this underpinning thing of these, what are Levin and Krakauer doing about complexity science, about teleophobia and teleonomic matter. Like I need to get some, and I feel almost like a interrogator or like someone interrogating like in a shady police. You're like, oh, you gotta give us some answers. In a much more intellectual highbrow way, but like I feel like there's some things here that I just have to understand about that are feeding some other work that are much broader and sort of the JoPro. This all is under the banner of the Future Center, which I'm hoping to like formally release soon as well. So a ton of stuff there. I'll pause for any questions or comments, and after that, say one more thing, and then I'll step away from the mic.
Yeah, this is good. lot of things to think about here. I like that you've kind of framed the sort of what Levin and Krakauer are doing in this way.
Oops.
Yeah, it's interesting stuff.
Yeah, I've sent this to you in Slack if you want to look over and advise. Like if I'm making any huge mistakes, please let me know. But otherwise, this is something that we can like talk more about over time. Like this is kind of just the post itself was me like, okay, Levin's this glossary, Krakauer's doing this thing. I need to sort this out, and it's kind of there'll be a lot more installments on that front ahead and so on. The last thing I'll give a little shout out to Arnav, because Arnav's we're basically about to release this. Arnav, an undergraduate student, did a lot in terms of taking ethical sustainability, or excuse me, environmental sustainability guidelines, environmental reports from big tech companies, and playing around with them and trying to make a sort of natural language processing analysis of them. And it was a big learning experience. He basically learned, he hadn't done anything with NLP before, but it was a cool like, hey, you know, how do you step into this new technology, but also like how do you deal with the fact that you know, what a company's reporting is limited or biased, and is it standardized, and what are the metrics? How can you meaningfully interpret them? So congrats to Arnav for kind of sticking with it through the whole process, and then actually making a write-up of some things. So this is a draft and hopefully be released in the next week or so. So I will I'll leave it at that and come back to normal discussion.
Yeah, so that was good stuff. I'm glad to see that NYCWiC went well. I was really interested in seeing some of the more social media stuff from NYCWiC. I don't know if you have time to do that, to go through maybe some of that again. And
oh, like the posts?
Yeah,
sure.
yeah.
It's kind of, it's a little disappointing because when I'm using let me try one thing
Okay.
to see if it can show up better, because when I'm doing it through my like I'm you know, kind of, I have admin view, and then the things that it shows me when I'm pretending to not be the admin is kind of like boring. Like yeah, okay, I think if I do it, yeah, okay, I'll do it this way. Because it's basically showing all the posts that we made, and it's like, I don't need to see the posts that I made. I want to see the other cool stuff people share with me. So I think this will work better. I basically just like another window. That's not accurate. That's where we had a conference
like
2
George.
years ago. But anyway, I don't know if this is gonna look very good.
It's fine.
This is
fine.
like somewhat visible, right?
Yeah, it's fine.
But yeah, just like really cool things like it was very like, even this poster was really good. There were a number of posters that I felt so bad for as a judge, because they were really good posters this year. Even on like, this was about cryptocurrency awareness and barriers, and it's kind of ironic because I like, yes, people are using cryptocurrency to scam people and steal a bunch of money in the world, but like this poster was really good, yeah, like here you can kind of see this here. Like she presented it really well. Like it was really cool. One of the things I wanted to say to if anybody watches this, I'll reiterate this. I kind of wish I had a chance at the end of it to come up and say to just say at large, we did it, but I really wanted to emphasize it. Like many of the people that presented their posters, you know, take like they really did a great job in the sense of, this was a mix of graduate and undergraduate students, and you could tell who had done it more than one time, but like, it's so good that they were exposed to really high quality poster presentations. Because yeah, some people, it was the first time ever presenting a poster and they weren't the most polished, but they could learn from graduate students or people that are the seniors that have done it. And it was just really good that way. So this is Jaya Pratha, who's I think was one of our panelists. And good stuff there. This is sort of commenting on folks. Who is this person? Culturally adaptive system for dietary modification. Another really good poster here. Yeah. We're hoping to get the professional photos out in another week or two, because this is a lot of these posts were me on my phone, but there's like an actual professional person there doing too. Saraf did this. This is the general update, but you can kind of see the pictures. Like this is the registry. Let me make this a little bit better. There we go. This is the registration desk. The naming's kind of funny. There's this thing. I don't know if it's the same where you guys are, but like there's this thing in like a lot of New York State things where we name everything like governor or like really. I find the naming to be kind of awkward because it's like you're naming other places in the country or the county that aren't the same there. So there's a little bit of confusion once again as what rooms are which, Governor A, Governor B, all this other stuff. But these are just different speakers here. Very good presentation here. Is the first keynote from Broadcom was Nicole Fagan. I think this is one of our NASA. Someone did work with NASA and they actually won the best graduate poster. I think she'll come out later. Yeah, Ravita did the People's Choice Poster Award. I think her poster was sort of the most people oriented. It was technical but not tongue tied, helping data professionals present insights with confidence. So it's sort of like a meta poster of how do you as a data professional talk about your stuff, or so a lot of people found that useful and liked that, so it won the best poster, which is kind of fitting and a little bit funny and ironic. But yeah, there's a lot of positive replies here. This is a whole big group from Farmingdale. They had like 50 people just hop off the bus. So whenever they arrived, it was just a lot of like, but it was good. What was this one? I can't see what the one this is. Anyway, I could just go through all these for like 10 minutes. So I don't know how much more you want to see, but there's just a lot of really cool stuff. Oh yeah, she had a fantastic poster too. She did one. Yeah, okay, this is the person who did the NASA work, a spectra of age and learning framework for modeling predicting exoplanetary atmosphere. But she had a very good poster and presented it well, and also was gave a research talk on it. So yeah, but just a bunch of cool stuff. This person too. I was a judge for her poster. She could have won as well. She was doing her poster was on enhancing telecom governance. So she was like, whenever you get complaints or stuff about telecom groups, how do you actually make it better? Which was quite relevant and interesting to hear. She primarily did work in India, but also some things carried over to FCC stuff carrying in the United States as well. But yeah, a lot of good stuff here. So, and then this guy thinks, this individual says the Dr. Rio's talk was really good, and I agree with that because that's me.
Yeah.
But yeah.
So what was the talk? Carla Rios talk about? What was the?
Her talk, I think. Oh, where did it go? is this, can you still see what I'm sharing? I
Yes.
don't know.
Yes.
Does it say the NYCWiC one or not?
Yes. NYCWiC.
Okay. I'm trying to see if it's listed here. Yeah. So, yeah, her keynote was explored how multimodal AI can quantify complex and often invisible aspects of human health, including chronic pain, addiction, and motor decline. So her primary work was as a longtime professional in the space of these sort of healthcare, a little bit of health tech, and designing some technologies and some the things in those spaces. And she went to three research cases. She demonstrates wearable data, which is something that I had a lot of experience in, speech analysis and interpretal design learning models can serve as digital biomarkers with real clinical impact. But then also this side, which I thought was a fascinating, really cool technology, really cool like life support, like exactly what you want a young, early career person to hear. Parallel to these, she shares her personal trajectory from electrical engineering to AI and healthcare, and then human variables in career growth, proactivity, navigating uncertainty, persistence required to thrive in a shifting landscape, and then highlights how we build systems to understand human health, and it's our own persistence that sustains us through uncertainty. And just like this is like kind of her final slide. You probably can't see it super well here, but a lot of commentary on motherhood, on things you'd be facing as a woman or as a minority, or facing as someone going through, being in quote unquote male dominated spaces, and just how to do that. Like it was very like a really cool blend of someone who's done really fascinating technical work. Technical work, and then like sharing their personal journey, and just like very, very, very nicely getting at like what was it like to live it and do that at a high level, and kind of sharing that wisdom. So yeah. Oops, am I still sharing this? Okay, yeah. All right. That's not what I wanted. Anyway, that's probably enough from that. But there's just a lot of
Okay. Yeah, looking through the program, what were some of the other highlights? Do you have like you pull up the program and show a little bit about that?
Is this showing you the program again now?
Yes.
I can't quite see all of my stuff here.
Yeah.
One of the highlights was lunch. The food was quite good, which is actually the thing people always comment on the most is the food at these events.
Yeah.
Whenever we do our surveys. I didn't get to, because I was an organizer and trying to handle stuff, I didn't get to like attend workshops in depth, but I heard and saw a lot of good things around. People really liked this panel, and there was also there's a bunch of things on social media which I don't know if I can easily show right now. It's giving me grief because I could do this before, and now it's not letting me do it. But this panel with these, we just mentioned Jayapreeta, but like these other speakers were, people loved the panel, and it was basically a career panel, but like, it's timely because, traditional ways of getting on jobs aren't, the world's different now, as we know. But I think people really appreciated the collection of people here, the experience, and the quality of the discussion at that panel was good. A lot of cool things. I could show so many pictures, but just on a lot of really cool. I think a lot of the workshops were quite interactive, and like people. When I would stop by those and saw them, people were really engaging with the material. So I think a lot of the workshops, I don't think there were any workshops that were like duds, to be frank, which is a good sign. This is the Spectra talk. A lot of like nice technical, like sort of niche technical things as well. The career fair was good. Graduate school fair also good. What else was a big hit? I did not see Nicole Fagan's talk. That was basically when I had a research meeting at that time, so I kind of stepped out. I heard the playtesting and the fun night was a success also. Yeah, that I listened to this great keynote talk, and then immediately, honestly, from 10 until everybody did a good job pitching too. I think that's actually one of the underrated things to be like put on my mentor advisor hat. It was a little bit awkward in the timing, and because you had PhD students and industry, mostly PhD, a couple industry folks, people who like had that experience, and then freshmen and sophomores, and there was a gap between how they spoke about things. But I think having everybody in the same room, seeing what worked, seeing people be nervous, seeing people make mistakes, seeing people be really polished, people who said the right things, people who didn't say the right things. I think it was the environment, like we talked about, like, in the past, the beyond demo or die type stuff, in terms of how do you create the right environment for people to make mistakes and learn and grow and see quality developments in ways of articulating things, which of course I still need plenty of practice on. It was really nice. It was I think this is the underrated moment, because I don't think anybody's gonna say, oh wow, I'm so glad I got to see 20 minutes of poster pitches for all these different people. But I think implicitly the way it was done, because you just came up, you pitched to the room, and it was mostly other poster presenters. It wasn't like a lot of people went to do lunch or do other things. But for the people that were there, I think it was incredibly valuable to do that and then to do the actual poster session. So I know I'm maybe biased because I was a judge, but I actually think this this section, from the keynote to the posters to the poster session to the judging and the discussion, I think that was probably the most valuable part outside of like the actual career focused panels. I think in terms of like takeaways, I really think this block, and for me, this was all like from 10 o'clock to basically to 2 hours, 2.5 hours straight, just running around the entire venue. I think it was really good, and people were. The poster session was cooking. It wasn't. A lot of poster sessions were kind of just ho-hum. Like there was a lot of action there. So I really think this section was kind of a critical hit or a critical win. It's the nat 20 on the Dungeons and Dragons dice, I would say. And then it was also really a really rapid cleanup too. So that's kind of nice for the organizers. I'm sure these were good too. I didn't really get to check these out that much because I was wrapping everything up. But it was a nice exit. The exit didn't take too long for closing everything down and all that other stuff. And people have opinions, you can come here and fill out our feedback form, even though that should say a different year. But anyway, it was good. Lots of good stuff there.
Yeah, I see they had some workshops as well, so that was good. Topic workshops. So that's great. Thank you, Jesse, for the update and a lot of the stuff on NYCWiC. I wanted to kind of go over that because, it's always interesting to see what's going on there.
I know I said this like 3 or 4 times, but I'm so thankful that even at undergraduate students now are really getting into cool stuff with the technology, and it's like finally a little bit of emergence from the GTP wrapper stuff. So I'm very personally pleased with that, because I think I'm still remembering the last time I was a judge at a poster session. I was just like, put me to sleep. So anyway, cheers to everybody involved with that. Cheers to the organizers and the students. And I'll be following up with a couple of them. I would even love to, I might invite a couple of students either to hear or something, or like for example, like, I don't know if there'll be a full Cognition Futures rating group rebirth, but like either that or Diginest or something with the complexity. I might invite a couple of students just to, present their stuff there, because it would be useful for those groups. So to be determined on that.
Yeah. That's great. Thank you. Yeah, so I'm going to actually present on something now. So the first thing I want to talk about is this agentive coding project that I've been working on. So this is actually a paper based on the stuff that I was originally planning to do for embodied intelligence. And this was not the thing that I presented at Embodied Intelligence this year. There was a different talk, which is actually quite interesting, and it's on our YouTube channel, called Embodied Models from the 80s. If you saw that video, it was, pretty nice. It's just basically all of the sort of underpinnings of what we think of now as like embodied agents and things like that, and just kind of the origins of it.
I'm sure that's been covered here in one of our meetings recently too.
Because
if not, I'd love to just go over that. Yeah, because I haven't been able to be here, and I haven't read that video fully, but like the title and the styling and everything, it was very cool and super appropriate too. And that's something that I'll save it for other time. We can go on this, but like, yeah. So I'm one question I was just about to type too. I see you put this on preprints.org. Do you like preprint.org for this kind of thing?
I mean, it's just kind of like, I don't think it would go on archive or bioarchive, and then I usually use archive, bioarchive, OSF, or this. So like OSF is usually like psychologically oriented papers or some of those things. This is just kind of different, so I wanted to use a different preprint server.
Okay.
Sometimes they don't, like archive and bioarchive don't accept certain types of papers. So
right.
Anyways, I'm using this. Yeah, I'm using this different preprint server for this. In any case, so yeah, that talk, embodied models from the 80s, it kind of fits this because it kind of frames like, you have a bunch of approaches that kind of come out in the 1980s and early 90s, and those approaches kind of inform what we're doing today. And so what I'm doing here is I'm kind of synthesizing a bunch of things that are going on in our world today of, different types of machine learning models, different types of computational models, and putting them together to sort of solve this problem. So the problem is that I want to build agent architectures that are embodied, but also have this sort of, these mixed properties. So if we think about like something that's specialized, if we were to specialize an architecture, say, for spatial cognition, we might hand code this or design this in a way that is specialized for spatial cognition, and that would be the function. And our conception of function is limited by, our ability to think of what the function should be that we want. So in other words, it's extremely goal oriented. We kind of have this series of tests. It performs well on a benchmark, and then that's our architecture. But in this case, what I want to do is I want to do two things. I want to evolve architectures for, maybe certain task settings. And when you evolve an architecture, of course, you can make it more sort of adaptive to the general sort of way of doing spatial cognition as opposed to, optimizing it for a specific task. So you have robustness, you have these other properties that we associate with, a complex system solution. But then on the other hand, I wanted to take different lineages of these genetic algorithms. I wanted to mix them together. into different meta architectures. So like for things like metacognition or multifunctional agents or things like that. So this approach, phylogenetic mixing, is kind of what I wanted to highlight. And what I did here is I used a combination of two agents. Well, actually, mostly Copilot, but then I also used a little bit of Notebook LM and the Gemini model as well. But in any case, I used agentive programming to build the models and to specialize them for this purpose. And so what I ended up doing is I ended up creating this pipeline for going from some sort of generative data set to like a selection mechanism, a genetic algorithm where I had selection, and then that would produce these evolutionary lineages of agent designs. And then I would find I would select the best ones, and then I built this framework for sort of putting those together, which was based on hypergraphs. So this is kind of going over the methods that I basically used to do. So this was all a proof of concept. I didn't actually build the agents, but I wanted to go through kind of the way in this pipeline would work. So, ideally you might give this feed data into this pipeline that define different neural architectures. Like we talked about last week, we talked about neuroecological architectures. And you might come up with those kinds of architectures and feed the components of those architectures into this pipeline. And so what I did was I modeled this with very simple shapes. And I also built part of the pipeline with a Bratenberg vehicle data set that I already had, which was basically where I built these different Bratenberg vehicles out of their components. And so this is an example of the shape data set. So it was like you had squares, circles, and triangles. Those kind of represented body parts. And then this was fed. So I have figure 1 here. If I can get to figure 1 here. So what I did was I fed this. I actually did the training in 2 ways. The first way is that I fed the shapes data set into the reservoir network that I defined. And then I fed this into a forward diffusion process, which was an alternate approach to this. So I had the reservoir network, the diffusion process, and I generated a bunch of combinations. So, and then I found the connections between them. So this was kind of building this network that was then we used, or I used the GAN which is a generative adversarial network. So the GAN would actually build the weight. Well, we'd get like this, basically this quasi-latent space from both the reservoir network and the forward diffusion process. And then the GAN would be used to generate the latent space and then find interesting connections within the latent space. So you would, in the reservoir network and diffusion process, you'd generate all these shapes, or you'd have these shapes and you'd train the model to find the patterns or the connections in that model. So you'd find similar types of squares, similar types of circles, similar types of triangles. And then with the GAN model, you would produce candidate latents for the latent space. So you'd construct the latent space, you'd map it to a metric space, and then you would generate shapes and other things that would be done with the discriminator. With the diffusion process, there was also this reverse diffusion step, which sort of produced the same approach. So, this is all basically taking this data set, creating a sort of a network of similarity, creating a latent space to select from, and then selecting from that latent space. And then the final step was to take that output and to apply a genetic algorithm that applied a fitness or a selection criterion. And so there were 2 selection criteria. One was for sort of similarity, or what was called sort of lineage specific relationships, and then another one which was a creative criterion, which sort of was analogous to convergent evolution, or when two lineages produce two different solutions for a similar function, like bird wings and insect wings, that sort of thing. So this was the pipeline, and it worked it out. And then I also had the Bratenberg vehicle data set, which was something that was also generated in a similar way. So these are some examples from the reservoir network based on the Bratenberg vehicles data set, where you had this body and then this internal model, which was a circle. These are just basically experiments to sort of get this ball rolling, to kind of figure out how this should work. And then eventually, this could be used for building more complex architectures that actually do things in the world. So I wanted to but I did want to demonstrate embodiment here. So then, these are the technical details still. And this is kind of the way this worked. So you would have these shapes that were generated in this space, and then this is sort of the output of a reservoir network, I believe. And then you would have this selection mechanism that resulted in this bottom graph. So this is the product of the GAN versus the GA model. And so you see that this is kind of clustered in one part. These shapes are clustered in one part of the latent space. There's also representing only triangles. It's selecting for triangles. So this is another example here. And then this output, which is the product of a GAN versus and a GA combined, produced this evolutionary tree. So it was able to produce evolutionary trees from the selected data, basically their relationship, either based on novelty or similarity. And then, of course, this is mapped to hypergraphs, where you're taking these different nodes and you're putting them into these collections of graphs within graphs, and then you're able to take that ensemble and apply it as a complex architecture. And so there are different ways you can do hypergraphs. You can do something like this, which is a nested hypergraph, or you can do a bipartite hypergraph, and this is based on the Bratenberg vehicle data set, which relates different aspects of the Bratenberg vehicle to these specific vehicle designs as featured in Bratenberg's book. The Bratenberg vehicle data set was interesting because I could break the Bratenberg vehicle down into its component parts. But in Bratenberg's book, he also gives information about the specific vehicle designs and about the behaviors. As they weren't precise in the sense that they were tested. He just kind of generated, this was a thought experiment on his part. So he was generating these behaviors and these designs. And so you can use this to kind of explore what's actually going on in that paradigm, which is very interesting because I think people have used Bratenberg vehicles in the sense of kind of building them into robots, but I don't think people have ever analyzed sort of the way in which Bratenberg vehicles, the whole premise of Bratenberg vehicles are presented, and the sort of the details in those descriptions. So, this is a good way, to kind of decouple, but also connect at a higher level, like morphology and sort of the architecture with the behaviors, with the function. Okay, so that was a little bit, and then this is a model of addressable phylogenies in Bratenberg vehicles. So, this is kind of bringing this idea together into a higher order representation, where you have these vehicles that have been decomposed in terms of their parts and then reassembled using this process. And then you can build a representation that allows you to evolve these reconstituted architectures. And so that's just kind of the things that I was laying out in that paper. So that was that paper. I finished that up recently. And I know we've been talking about the sort of the connections between reservoir networks and diffusion models. and this is kind of where this is coming from, but I actually have some other stuff with tables kind of showing the kind of relationship between the two, and I didn't get into that. I mean, it's in the paper a little bit, but there are sort of pros and cons for using either, one versus the other. So you might use, say, for example, a reservoir network to represent nonlinear outputs. If you want to preserve nonlinear outputs in your data, you would use reservoir networks over diffusion networks. And there's certain benefits to diffusion networks as well. There's, I guess, greater interpretability. It's easier to run on, to get in, to run on hardware basically, and the like. So there are a lot of pros and cons. I don't have the table up in front of me, but that might be something else that maybe is more of a blog post, but still, that's available. It's like Morgan has some thoughts about it.
Yeah, no, I mean that's really important right now, I think, to look at. And if you've got preprints, I'd love to be able to dive in.
Yeah, I'll put the link in the. Well, I can put it in the Slack as well.
Sure.
Yeah. All right.
That'd be great. Like I said, I really want to circle back to this understanding of reservoir networks and how they're being used, what they're good for. I mean, that's interesting to see what they are good for. I mean, over some of these other techniques that are certainly more in the following this AI wave of things.
Yeah. So I guess a lot of people will use them as. I mean, like I saw a very good talk on network science, where they were using reservoir networks to reconstruct networks from basically a matrix that's network science friendly. So you have a network of interactions where the connections are well characterized. You can't just give it unstructured data and get it. You have to have some structure in the data. It doesn't require labels necessarily, but you have to have that structure kind of in the data set. And then, of course, you can extract different motifs and you can put together, reconstruct networks that way, which is interesting. I thought that was a good application of it. Other people are experimenting with like connectomes, where you have the same thing, where you have these well-defined network structures. You can extract motifs and then reconstruct the network. And I mean, so it's not for every problem, but I think like for stuff like that, I think it works out pretty well. The question, of course, and I had, and this is more generally speaking about like when you hand a data set to an agent to get it to like extract things, is like what is the level of structure you need to get like a reasonable answer? Because I've done some experiments with data sets, and this isn't for this paper, but it was another case where I gave it some data and it just kind of made up nonsense. So, how much structure do you actually need to give the agent to train it to give you a good output? And, I think like the Bradenburg stuff, I was surprised because it extracted that from the book. It has like, but still it's like, it's producing states that I would like to refine. Or, if I were to hand code the data set as an expert, I would have a lot more precise data, I think, on some of these things. Or you could break it down into better categories. And then, again, it's like, this is something that you could spend a lot of time on, getting this exactly the way you want it. And then you'd say, well, why do you need an agent to help you with this? You know what I mean? Like,
Yeah, it's have you thought about what was particular about that data set, or
About
you
which
know,
one?
like, well, the one that you gave it the data set, and it gave you, you know, like kind of,
Oh,
I mean, I assume not gibberish, but like it essentially made up something.
well, so these were some of the DevoWorm data sets that I had just kind of lying around, and I fed it in.
Yeah,
And it wasn't
yeah.
structured in the sense that it had a lot of metadata in it. It was just kind of like numbers and labels and
Mm,
things like that. And it
mm,
would make
mm,
it could find patterns, and like I trained it with other
mm.
papers, so it had like a pretty good model. But then it was like producing relationships that didn't make any sense, which is like the thing. And then so it's like, well,
Okay,
wait a minute. I think I know what the problem is here. It needs like some
okay,
information about maybe
okay.
ordering effects or things like that. So it's
Sure,
like you
sure,
can
sure, sure,
see
sure.
how, yeah,
So it was still there. There was a method to its madness.
well, yeah, the
I
method,
mean,
yeah,
you know, and there's right. Okay, okay. So that was maybe more of just like, yeah, like like give it unstructured data, and it will find things that are actually like superficial and
yeah.
things like that. But then over interpret them.
Well, no, well, it's kind of like, you'd have a good conceptual model, but then the
Mm,
actual relationships. It would be like if you knew that you needed to build a bivariate graph, and you knew you needed
yeah,
to do a regression on some data, but then the relationships, the data points were kind of like misinterpreted incorrectly, or it was like you didn't have certain order effects that you knew were in the data set, but you didn't tell the model about necessarily. So it's like, how do you get? So is it a matter of labeling the data, or is it a matter of like giving explicit instruction about the ordering effects, or what is it? Because I mean, that's of course when if you're doing secondary data analysis, that's exactly the type of metadata you need to do to do that properly. Like when you
right.
see archived data sets, sometimes people will just dump data, numbers into a file, and you'll like say, "What is this? How do I use this?" So it's kind of
Yeah,
a similar problem.
yeah, yeah, yeah. The yeah, for sure. Um, sort of aside, but just wanted to mention that the Allen Institute has like I attended their Tuesday meeting where they talked about their new OpenScope data release.
Okay.
So this is cool. It is super big. It's like 56 gigabytes. I mean, I don't know. That's not. Was it gigabytes or was it terabytes?
Probably terabytes.
Um,
Yeah.
I think it's terabytes. Sorry. Um, I'm so old I can remember when gigabytes were big.
Yeah. 56 gigabytes would be like, you know.
Yeah, yeah, yeah. Well, that's bigger than my. That's bigger than my. Yeah. I'm dealing with these very small memory systems.
Right.
You know, this is actually megabytes. I mean, in terms of like the onboard memory, you know.
Right.
But just it's the Nerd Data Without Borders rehacks is like an event over the summer that is at Genelia where they do secondary analysis of like neuropixel data sets and things like that from the Dandy archive. But OpenScope is really interesting because OpenScope has got I mean, this is new, you know, like this is the new data. Yeah, like it's going out to everybody,
Right.
and cool
Yeah.
project though.
All right. So why don't we call it a day then? And glad to see everyone's doing well with their projects and things like that. And yeah, thank you, Vidhi, for showing up. And yeah,
I appreciate how hard Claude worked this week.
oh yeah,
Yeah, yes, really put in the time.
yeah.
Is there anything we should schedule for discussing next Friday, or like before the next meeting?
Oh, for
Does
our
it start
first.
next Friday?
No.
Well, we'll start like probably in 2 Fridays, I think, because I think
Okay.
this 2 Fridays from now is May 1st. So we could do that, and then if you have ideas, let me know.
Okay.
Like what you want to do, and you can bring something to that meeting. I mean, that'll be just like the introductions. I'll probably do some community introduction and maybe something related to that. Just kind of an introduction of maybe what you do or what you want to do over this summer or whatever. That might be good.
Okay. Sounds good.
All right. Thank you. See you next week.
All right. Take care, everybody.
Take care.
Bye.
Bye.
Yeah.
Hey.